IXR DXR Modality Manager for Philips Multi-Vendor Services. Today on this webinar, we are going to talk about basic X-ray, C-arms, and portables. Plus, we have Dale Lehman from All Parts Medical Technical Support Group to talk about an exclusive remote tech support program called REACTS. So now, let's go to the outline. Within this webinar, we are going to talk about the history and fundamentals of X-ray, and then we'll talk about where do you find general X-ray in use, the type of general X-ray equipment, what are the components that make up a basic X-ray machine. We'll be talking about the introduction to portables and C-arms. We'll look at the major components that make up a portable and C-arm and some of their common failures. And then we'll conclude with Dale Lehman from All Parts Technical Support talking about REACTS Mobile. On November 8th, 1895, Welcome. My name is Kevin Millison. I am the IXR DXR Modality Manager for Philips Multi-Vendor Services. Today on this webinar, we are going to talk about basic X-ray, C-arms, and portables. Plus, we have Dale Lehman from All Parts Medical Technical Support Group to talk about an exclusive remote tech support program called REACTS. So now, let's go to the outline. Within this webinar, we are going to talk about the history and fundamentals of X-ray, and then we'll talk about where do you find general X-ray in use, the type of general X-ray equipment, what are the components that make up a basic X-ray machine. We'll be talking about the introduction to portables and C-arms. We'll look at the major components that make up a portable and C-arm and some of their common failures. And then we'll conclude with Dale Lehman from All Parts Technical Support talking about REACTS Mobile. On November 8th, 1895, a physicist named Wilhelm Conrad Röntgen discovered by accident X-ray when experimenting with a cathode ray generator. He found that this new ray or radiation would penetrate all types of matter. He used his wife to create the first X-ray image of her hand. Röntgen called this newfound radiation X, which stands for unknown, but we know it as X-ray. In 1903, William Coolidge invented the first X-ray glass tube. The problem was people were dying from this new X-ray. But in 1920, they found that if you could safely use X-ray if you use the following steps: time, distance, and shielding. Limit the time in the field, limit how far you are from the source, and use lead shielding. All light and radio waves belong to the electromagnetic spectrum. Microwave and infrared bands are longer than visible light, but UV and X-ray and gamma rays are short wavelengths. It was found that a crystal could bend the X-ray the same as light through a gradient. It was also found that X-rays are capable of penetrating some thicknesses of matter. Medical X-rays are produced by letting a stream of electrons to come into a sudden stop at a metal plate known as an anode. Images produced by X-rays are due to the different absorption rates in the different tissues and bone. The calcium in bone will absorb most of the X-rays, and on the image, it looks very white, whereas fat and soft tissues absorb less, which make them look gray. Air absorbs the least and looks black. So where do we find X-ray in use? We find it in hospitals, clinics, mobile providers, which are trailers. We find it in the following departments: emergency rooms, urgent care. There is diagnostic or treatment or pathological imaging. What type of X-ray units are there? There's analog and digital. An analog system needs film or CR, which is computed radiology, to create an image. Digital systems uses a digital plate to create an image. There's treatment departments, which treat cancer cells, which is radiation oncology. Diagnostic, which is used for looking at structures in and on the body. We have RAD departments. We have RAD fluoral departments, mammography, and bone densitometry. General X-rays used for diagnostically looking at soft and solid objects within the body, such as a chest image. They might be looking for pneumonia or cracked ribs, or they look at kidneys by the way of using a liquid called contrast, which makes the vessels within the kidneys turn dark. R&F or fluoral systems are used to create moving images, such as if you want to look at blood flow through a vessel, or doing what they call upper or lower GI, where they look at the intestines. This is done again by using this liquid called contrast, which makes the whatever it goes through turn dark so that you can see it. But the thing about an R&F room is you can do both RAD images and moving fluoral images. Treatment equipment are used to eradicate cancer. They are very high powered. They can output either a high dose or a low dose, depending on whether they want to penetrate deeply within the body or just on the skin. They use a precision multi-leaf collimator, which after putting in a CT scan of the area of interest, they create a plan which makes those collimators create the shape of that lesion, and they only radiate that portion and not just completely blast the body. So the pathology equipment is used to image samples that they take from supposed cancerous areas. What it does, it gives them an image that they can determine whether it is cancerous or not. This device can either be in a surgical suite, it could be in pathology in the lab, and it could be portable too. What are the components that make up a basic X-ray unit? You have to have these basic components, and every manufacturer has to have them somewhere within their system. You have to have a mains, which is the incoming power from the hospital. That goes through a voltage compensator. This device usually is a transformer and holds the voltage on the other side steady. As we know, our power is not what they say it is. Some kind of voltmeter to make sure that that power is correct. We have to have an exposure timer. In X-ray, we turn the X-ray on for a period of milliseconds and we turn it off. Well, this circuit is what does that. Pulse duration, that circuit is a circuit that sets up the duty cycle on the high voltage rectifier. It determines how much power we're going to output. We have to have a kV selector. kV is what we use to penetrate into the body. From there, we have to have a high voltage transformer. We have to take whatever our incoming power is and boost it up to over 10,000 volts to feed the high voltage rectifier. The high voltage rectifier then sets up the duty cycle. And what I mean by that is if you look at a sine wave, it's how many times it turns on and off, which determines the amount of power is outputted. MA meter, we have to have one of those so that we know how much electrons we're going to send out. And we have to have an X-ray tube. Within around that X-ray tube, we got to have a filament control. The filaments are like a light bulb. They're little coil filaments that create this electron cloud that we need to send downstream to the metal plate called the anode to create the X-ray. So we have to have something that would control that so we can control the output. We have to have thermal overload protection because 80% of the power that is generated is in the form of heat, creates heat. So we don't want to burn up our X-ray tube, so we have to have some kind of circuitry that will shut that down. And then we have to have a rotor control, which there's a motor that's hooked up to an anode in there, and it rotates. And that beam that comes off of those filaments can burn through that metal if it isn't rotating. So these are the basic components that are necessary in an X-ray machine. Every X-ray system has a control panel. On the control panel, we need the means to control kV, MA, and time. Also on the control panel, you will find pre-programmed selections. So the technologists can just press a button and have it set up to take a chest X-ray on the chest stand. We also have exposure buttons on the control panel. There's displays that display the kV, MA, and time, and other relevant information. They may also display error messages. Every X-ray unit needs a generator. The generator creates the high voltage, which is around 10,000 volts, which is supplied to the X-ray tube to create the X-ray output. The generator is controlled by the generator console, which we talked about in the previous slide. Different manufacturers such as GE, they have their standard Jedi generator, which you'll find in probably 95% of all of the equipment they manufacture that generate X-ray, from CT to basic X-ray to RNF to cath lab. Siemens, as shown here, this is an IT generator. This is used in Maltech's M systems. Citical is used in multiple lower end units. They are very stable. You will find these in the diagnostic type X-ray units in a doctor's office. Also, the CPI is found in the doctor's office. This particular one that is viewed here is actually from a Rad Pro manufactured by Picker. Within the generator, there's that high voltage transformer assembly. Internal to it, there is diodes, capacitors, and inductors to take the low voltage and boost it up to the voltage necessary for the X-ray tube. Some tubes on, let's say, a rad flow room, that system has an overhead tube and a table tube, and the same transformer then supplies power to whatever the selected tube is. And in order to do that, they have switches to switch the filaments and also to switch the high voltage cables so that only the selected tube gets the energy. The rotor control board supplies power to the stator, which is a motor in the X-ray tube. The stator turns the anode. In some systems, there is two-speed rotors. The higher the kV, the faster the rotor turns to keep the electron beam from burning a track or pitting the anode, as seen on this slide. The heater or filament control board supplies low current power to the filaments in the X-ray tube. The filaments then create an electron beam by thermonic emissions. This electron beam is then pulled to the positively charged anode, which then strikes the anode surface and breaks up into 20% X-ray and 80% heat. The X-ray tube comprises of two sections, which are enclosed in either a glass or a metal enclosure filled with a dielectric oil that is used for cooling and isolation. The negative section of the X-ray tube is called the cathode. The cathode houses the filaments. The second is the positive side, or anode side. It houses the stator, the rotor, and the anode. Now that we have created our X-ray beam, we need a device that will shape the size of that X-ray beam to the subject or surface that we want to X-ray. That is done by what is called a collimator. Within the collimator, there is metal barriers or blades that we can bring in on all four sides to make a different size of field. There's also diaphragm types where it's round. We can squeeze those down to a certain size. But how we know what size of X-ray we have is done by the calibration of a field light to X-ray field. This way we know that we see the light on the surface, that is where our X-ray beam is. We need a way of turning the X-ray beam on and off fairly quickly. So there's a circuit within the X-ray machine called the AEC, or automatic exposure control. This is comprised of a control circuit, an ion chamber, which then the ion chamber reads how much X-ray has hit it. And at a certain point that we set up on our control, it turns the X-ray off. Now that we have an X-ray beam, we need to start putting components in place that will give us some kind of an image. One of those types of components is called an image intensifier, or short II. These devices take X-ray photons from the patient and turn it into a photoelectron, which then is moved up through the II via coils to a fluorescent screen, which then glows a visible light. And on that side, we attach a camera, which then sends a signal to a monitor. There are very many different types and manufacturers of cameras out on the market today. We had in the past glass cameras, but those today are no longer found in the market. What you will find is the CCD camera, which is similar to the camera on a cell phone. Pictured here, I have two different versions of cameras that all parts sells. We have the Thales camera that is on a P500. This camera also can be found on many Siemens RNF rooms. There's also the OEC 98 camera. These cameras take light and turn them into electrical signal that can then be sent to a monitor or some kind of storage device. The second device that we see on the market today is called a detector. The detector takes X-ray beam and turns it into an electrical signal. Within the detector, there is a crystal that glows similar to the phosphoric screen on a II, which then is picked up by some photoelectronics. There is two different types out there in the market. We have a fixed detector, which shown here is the detector from a GE Definium 8000, or we have a couple different types of portable detectors. They either can have a cable attached or they are wireless. The X-ray tube is mounted to some kind of tube support, whether it be a floor-mounted tube support, a ceiling-mounted tube support, or a U-arm, which is used for stretcher work. Now that we have our X-ray tube mounted to a tube stand, we need to have a device to keep the patient lined up with the X-ray beam. There are different components. One of them is like the U-arm, which has the detector attached at one end and the X-ray tube at the other, or we have a standard table where the patient lays flat on the table, and the table can either have four-way floating or it can raise up and down. We could have a multi-purpose table, which can be used for multiple different procedures. And then there's the wall stand, which is used to do chest X-ray. Within many of the positioners, there's a device called a bucky. The bucky was originally used to mount a cassette with X-ray film in it. But in today's system, the Bucky is being used to correctly position a digital detector under the patient or behind the patient. Now that we have our digital image, we need something to view that image on. So in the market, we got multiple different manufacturers who make monitors. There's general purpose monitors, such as a computer monitor, and then there's the diagnostic grade monitors, which are used by the doctors to create treatment plans. You will also find in the cath lab a large 70-inch monitor, which you can display multiple images on. Now that we know about all of the components that are necessary to make up an X-ray machine, let's talk about portable X-ray and C-arms. Where are portable X-ray and mobile C-arms used? They're used in the emergency room. They're used in surgical suites. They're used in patient rooms. Also, you will find them in clinics, outpatients. You find them in orthopedic and endoscopy and pain management departments. What are they used for? They're used for emergency urgent care, orthopedics, cardiology, and angiography. Listed here, I have two units, the OEC 9900 and the GE AMX4. All Parts Medical has a very large selection of parts ready for shipping on these two systems. There are many different types and manufacturers of C-arms on the market today. The C-arms that I have listed here, All Parts carries parts and training for each one of these. The OrthoScan FD and Hologic Insight FD are used for extremity work, such as imaging of the hand or elbows. The Siemens Seos Fusion, OEC 9900, and the OEC Elite CFD are used in multiple different departments, such as the cardiac department, the pain management department, ortho department, and you might find them even in the ER. There are two different imaging systems within the C-arms today. You either have a system with an II, which is the 9900, or you have a flat panel imaging system, which has a digital detector like in the Siemens Seos systems. In the C-arm, such as this OEC 9900, you have a generator, you have an X-ray tube, you have a collimator, you have an image intensifier, and you also have a CCD camera, all to create the image. A lot of these systems come with different size C-arms. Some of them are motorized, where the C-arm actually has several motors to do 3D work. Most of the C-arm systems out there has a workstation trolley monitor cart assembly within their system. This usually provides power distribution, video processing and display. They have external connections to go out to other monitors or other storage devices. You could have hard copy, which most of the hard copy are papered this day. And also there's Ethernet to send DICOM images out to PACS. With OEC, all parts carries many parts that are associated with this system. We have intensifiers, we have CCD cameras, hand controls, foot controls. We have X-ray tubes in stock. We can get you battery packs. We can get you wireless DICOM components, dual monitors, replacement, the remote control interface, and we also have a good selection of new interconnect or umbilical cord cables. Some of the common failures that you will find within a C-arm system is diminished dose output, which is usually one or two things. It's either a bad low battery, bad X-ray tube. We have weak or discharged battery packs. We have damaged high voltage cable assemblies. We have communication failures, bad low voltage power supplies, broken interconnect or umbilical cords, cables. We have poor image quality. We can have a bad X-ray tube, not enough power coming out. We have bad processing in a workstation. Our IIs could be weak. We have lack of DICOM communications, which usually is the motherboard within the workstation. System won't boot, possibly bad BIOS settings or a dead coin battery. KV and MA ramps to max. Well, the system can't see any X-ray, so there's probably a broken video cable, or we have a lack of high voltage to the X-ray tube. Now let's talk about portable X-ray units. They're very high. There's a very high install base out there. They're very reliable. Some of the major OEMs are GE, Philips, Shimatsu, Siemens, Canon, and Samsung. On this slide, I have listed the systems that we have parts and training for at All Parts. There's the AMX4 Plus, the AMX 700, the Carestream Revolution, the Siemens Mira Max, and Shimatsu Mobile Dart. Some of the common parts that or components you will find inside of a portable X-ray machine: you have an operator's console, you'll have battery packs or capacitor banks, you have battery charging circuits, of course an X-ray tube, you must have a collimator, you have to have an X-ray tank, the X-ray cables, and then because it is a portable system, we need some drive system, which is comprised of motors, wheels, and control handles. So in the portable X-ray realm, you have two types of systems out there in the market. You have an analog system, which is just a standard analog system that used to be used with film or with CR plates, have been now upgraded to digital via a third-party upgrade, which included a external monitor, imaging computer, and a wire or wireless detector. Listed here, I got two manufacturers, the Carestream DRX and the Konica Aero DR. On the other hand, you have the manufactured digital portable systems, which have built-in imaging computers, and they have digital wireless detectors, such as the Shimatsu Dart Evolution, the GE Optima XR220 or 240, and the Siemens Mira Max. Here are some of the common failures you might find in a portable X-ray unit. Bad batteries. They become resistive. Most battery packs only last about 4 years. Bad charging circuits. Drive motor errors. Bad drive control boards, drive motors, brushes, bad handle controllers. Generator errors. Again, bad batteries. Most of the problems with KV usually end up being bad batteries. Batteries not able to provide enough power. Bad X-ray tube. Bad rotor controllers. Bad CPUs. Bad cables. The other things that happen are detectors being dropped and artifacts showing up and batteries not good. Please give All Parts a call. We have all these components in stock ready for shipping. We also provide technical support, and we have training on a lot of different pieces of equipment. And with that, I'm going to hand it over to Dale Lehman, our technical support engineer, who's going to be talking about a wonderful program called Reacts, which will cut down your repair time.
Welcome to the Reacts part of the presentation. My name is Dale Lehman. I'm with All Parts Technical Support Services. Reacts stands for Remote Education, Augmented Communication, Training, and Supervision. All Parts is proud to introduce Reacts. Reacts incorporates innovative tools like augmented reality, sharing files, pointers, overlays, and other things that can help us help you diagnose your problem. Reacts is a communication platform designed for the healthcare industry. Its creators built it to be HIPAA compliant and secure enough to support telemedicine, remote education, and technical support. Philips has acquired Reacts and has been in long-term partnerships to integrate their technology. We at All Parts are launching the app-based communication tool to improve our customer support. Why Reacts versus other video communication? HIPAA compliant. It complies with security and privacy laws and regulations, protects the patient data, and headless servers. Reacts also allows us to freeze images, use pointer tools, share content, images, documents, and desktop, overlay live videos onto a frozen image. Reacts is a secured video communication. Reacts can be accessed in 3 different ways. Windows desktop application, a web-based application, or a mobile application that can be downloaded on your Google Play or Apple App Store. When do you use Reacts? When you need assistance troubleshooting. It's like having another FSC there on site with you. If I have multiple parts or high cost parts that I need a second opinion on. There are 2 ways to create an account, reactively or proactively. It takes about 15 minutes to set up your account. To set up your account, log into www.reacts.com and set up your account on your web desktop. Set up a username, which will be your email address, and a password, something easy you can remember. You can sign up on Reacts using your phone. After you once sign up with your address and password, you will receive an email to confirm your account. This is an example of an email sent to you when you are added. This is a demonstration using Reacts to use the pointer to show the FSC where to go to and where to look for his problem. This is a display of an overlay that we're capable of doing. This is an actual account where we're working with an FSE with the components on the left and the block diagram on the right, showing the flow of the signals. You can actually get tutorials on the Reacts page. You get following one Reacts web mobile video session. We'll show you how to access the web and mobile device. You also have different interfaces with video and also shown different capabilities of Reacts. Thank you for your time. If you have any questions about Reacts, feel free to contact us at All Parts Medical, 866-507-4793. Thank you.